Hi. So we've been showing you that the simulator programs can just be transferred to the PIC fairly straightforwardly. There's a few things that I want to make clear. I want to give you a sort of a starting point for all the future projects you build that you're going to load on the PIC. It's this file right here, the PIC XC32.c. This is a file. It's a very simple file. All it does is print hello world, but I wanted you to have it as the starting point for any other programs you write. They'd all basically expand in the main here. Okay, so what does it look like? Okay. Well, the first thing are these include libraries. Okay. This is the library that knows all about the PIC, what all these special function registers are, what memories do what. So that's crucial. It knows about our chip. The second one is plib.h. That'll be the peripheral libraries that we use to do things like control the UART so that we can talk to the PuTTY program. But it'll also be for things like PWM, ADC, flashing LEDs on and off, many, many things that we're going to do. Now, one of the annoying things about this library is it used to be part of all the XC32 libraries, but they've separated it out. And now that they've separated it out, it tells you it always needs to be loaded. These two lines here just prevent like 20 or 30 really annoying warning messages popping up during the compile. We don't need to see them. We've got it installed. We know what we're doing. We don't need to do that. So these are suppressing warnings. Okay. As well, we're always going to want to use C libraries. If we're almost always going to be using printf, so we're almost always going to want to use the standard input-output library. But other directories or libraries we would use would be things like the math library for using the power function or exponential and natural log. I've also given you a couple of libraries I've created to make learning the PIC much easier for you. One of them is the configure UART library. Okay, that's this file here, the header file, and the source file. What they is a program that uses the peripheral library to make the serial connection. Let's look at configure UART.c. Okay. Down here, there's a function, this open UART2. That's in the peripheral libraries, right? And so it's making a whole bunch of selections to set up the connection for me. Also in here are these peripheral library instructions that configure the pins that we're going to use for TX and RX. Okay? So they're all peripheral library stuff. Okay? We want to be able to communicate, so I gave this to you without having you to build it all. Again, you'll notice, get rid of those warnings up here. Okay, I also gave you this PuTTY program, right? In PuTTY, right, there's this little function whose whole job is to clear the screen. It's just a print statement, right? Since it's a print statement, I got to tell it in this library that I need the standard input output. Okay. As well, what's in here is this thing, configuration bits. A configuration file, let's have a look at it, is a bunch of commands involving what are called pragma configs, right? that are setting higher level settings for the chip. For one thing, I've been telling you that this chip works at 8 megahertz. It can work at other speeds too, and this is the statement that makes it work at 8 megahertz. We didn't want you to encounter all this stuff early, so we're giving you a configuration file that sets it up to all the basic connections that we want. Later we'll learn how to change some of these on our own. Okay? Just a few of them, not all of them. In Run, you can also set the configuration bits. There's a bit more information here about the possible settings. So if you come up to a setting, right, it'll tell you the choices you get, right? All the possibilities. Okay? They're mentioned, the important ones for us are mentioned in the manual. You don't have to worry about them too much. But if we did want to make changes, then we could generate the source code, and that could be another configuration bits header for us. We'll play around with different versions as we go. Make that small again. Okay, come back here. As well, I do this usually in my programs from now. I define two speeds, the system frequency and the peripheral frequency. Remember, the chip works at 8 megahertz, that's the system frequency. The so-called peripheral bus clock frequency are the speeds that things like the UART module, PWM are working at, right? Right now it's set in configuration bits to be the same, right, as the system frequency, but I want those two different numbers because we could change them later. And in my code, we don't want to always be changing a number, right? So I am going to use peripheral frequency. So later, this might become 4 million or 1 million, and I wouldn't have to make any changes except up here at the top in this definition. Okay. In configure UART2, maybe just go back a second and say, for you to configure what we want, you just need the peripheral frequency, 8 megahertz here, and the baud speed. Back in configure UART, right? What's happening is there's a calculation right here. Okay. Right, UBRG equals the peripheral frequency divided by 16 divided by the baud rate plus a half minus 1. That finds a number, UBRG, that's necessary to establish the baud rate between the PIC and PuTTY. Okay. There's more about that in the serial communications chapter of the manual. Okay. So, if you want to write a new project involving the PIC, this is normally where you would start from. Okay, I think that I've covered everything here, so we'll call it a day.